I'm Sean O'Brien with the Internet 2 Net Plus team, and I'm here to introduce you to a highlights video of how research and education institutions made use of cloud services in the Net Plus portfolio to support teaching and learning. As we all know, cloud services played a really important role in supporting the virtual campus when we couldn't easily get together in person. As part of these highlights, you'll hear from various research and education institutions about how some of these services supported them in carrying on their missions. Examples include hearing from Iowa State University about how they used Panopto to support lecture capture, hearing from a panel of various universities talk about the lessons they learned teaching online that can be applied moving forward in the future. You'll hear from Indiana University talk about how they're teaching with Google Cloud Platform. And finally, you'll hear from Portland State University talk about how they're teaching cloud security. You know, one of the great things about working in the research and education community is that it truly is a community. During a really difficult time, community members took time out of their schedule to tell the stories of the great things they're doing at their institutions as part of our I2 Online series. And I hope you take a minute to check out some of these highlights in our recap video to learn about some of the great things they're doing. On behalf of the entire Internet 2 Net Plus team, I wish you all a great start to the 2021 fall semester. And we look forward to seeing you at future I2 online sessions and other Internet 2 programming. Thank you for your contributions. Thank you for your support. Now let's check out some of the highlights.
When we moved to the hosted environment, we made the decision to switch from that kind of broken down organization structure to a more centralized single instance of Panopto. So we use the folder structure in Panopto that's come at Iowa. So beyond the traditional video content management system that Panopto kind of has as independently, we have Panopto integrated with Canvas. So that's both the timely lecture capture that happens. So a lecture that might happen in a classroom, and then they want to post the recording of that at a later time for students to review, as well as short videos with a short shelf life. They might be important for a certain context within the class. That also contains content that's evergreen. So maybe a pre-recorded lecture, a flipped classroom, something like that. That content that's used year over year. We've got many diverse uses of the platform across campus. Obviously lecture capture. We do some student assignments in Canvas. So if a student wants to introduce themselves to the class or make a video of a presentation, Panopto is kind of our primary use, our primary platform for that need. Promotional and marketing materials. There are some other things that we do with that outside of Panopto, but there are some marketing materials inside of Panopto. And then training materials for training courses, things like that. And then we've got a few podcasts that are hosted out of Panopto and syndicated to the Apple Store. Yep.
Really quickly, Dave, there's a question from Mary Beth. Is your video retention policy the same as your LMS retention policy?
Okay, yeah, excellent question. So we don't have an official LMS retention policy yet, I'll say. We had kind of been working on that, on the governance part of that, a few years back, and then we ended up migrating from Desire to Learn, or LMS at the time, to Canvas, and then shelved the whole discussion around LMS archiving and things because of that change. I think that's still like an open thing that we'd like to get back to, and it may be a different approach for the LMS retention as well. That might be, we were talking, maybe it's 7 years, maybe 4 years. I think 4 years was too low. Maybe it's 5 years in one semester, 7 years in one semester. but as of today, we're not doing anything in the LMS for content retention, but that's sort of next on our list of things that we're broadly considering about content retention things. And then I think Melissa had a question on every lecture is recorded for every course during the pandemic. At Iowa, that choice was left to faculty members to choose if they want to record their lectures, every single one, or not. But if they do record, that's stored in Panopto, and that falls under the 4-year retention thing. And there's also some instructors too that have gone back to things. Oh, I recorded this last year, I'll reuse that now for this year's part. And that opens up all sorts of possibilities for like flipped learning, flipped classroom, and things like that. But that's a whole other topic.
And the first one, we're going to start off with Corey. Corey, it's a bit of a two-part question. First, what are some of the positive outcomes from the experience you've had at the university in the last year? And the second piece is what are some of the weaknesses that the pandemic surfaced?
Sure.
And how did you address them? Sorry.
Yeah, that's a great question. And I think if I really look at the meta level, I would say the biggest positive that we have seen out of the last year is the hard lean from our faculty into student-centered learning and really flexible learning practices. In some ways, maybe I'm a little surprised that our faculty embraced it so readily. They really did take advantage of the opportunity, this unique opportunity when everybody is remote, to think about how they were delivering their teaching and really move toward more of an interaction model and less of a presentation model. We've talked about how important our Zoom and video capture and recording capabilities were, and they were important in helping us to lay a foundation, but the faculty have rapidly been moving, especially in this spring semester, to how can we create more interaction and make this more like what we were able to do organically in a classroom. And I love seeing that interest from the faculty as they begin to break down some of the mythology that they've had in their own minds or that's been just out there, that my discipline can't be taught online, my discipline can't be taught virtually. I think a lot of them have had their eyes opened, and that's great to see. And what's really neat is as their eyes open, some of the more innovative ideas are coming from those faculty who didn't necessarily think it could be done. It's really, even in assessment, moving to more show and do kinds of activities and moving away from recall and recite. And I think that's where, as educators, we've all been hoping that we could move. And so what a year it's been. Some of the weaknesses that maybe we've encountered in the last year, I'm just glancing at some things I wrote down here. I think one of the hardest things through this past year has just been, I guess, what I would call the noise. The noise and static of the hundreds and hundreds and hundreds of message coming in from ed tech vendors about how they can solve our problems. And they're just hitting faculty members. They're hitting everyone with this blanket of messaging. However, not a lot of these ed tech solutions have thought about, do they scale? How do they deal with privacy? Do they use standard space connections? How do they interact with the other parts of our ed tech stack? They're very siloed, and I think that's a weakness that we're seeing in the ed tech industry in general. And you have to carefully vet whatever you bring into your tech stack to make sure that you are dealing with someone who has thought through scale, interoperability, just being a good player in the university environment. And in some cases, we had technologies that we thought would work well, and they stumbled and fell flat on their face, and we've had to pivot and work around those. And I guess the other weakness is just that the there are a lot of people that jumped on the online bandwagon early on, and we had the joy of working with faculty who wanted to be building online courses. This year, we have a lot of faculty who never wanted to teach online. They're reluctant. And in some ways, I'm a little worried, and I hope that we don't see this fall backward, 2 steps back, as we now take a whole new group of faculty who are new to online learning, and their courses and the way that they're building them are kind of old practices, and we've got to get them rapidly up to speed. One of the ways that we're really engaging faculty in this conversation about moving away from presentation to interaction, I mentioned the Adobe Creative Suite, and that really seems to be something that gets faculty interested. It's not a gimmick. A lot of them know about the Adobe products, what they can do. The question is, how do you weave those into actual learning activities and get students engaged with that personal learning that they can do in the creative space? And then how do you bring that into an artifact that's accessible? And so we've really been working a lot with how to create activities that leverage Adobe Spark, portfolios, and driving deeper into some of those digital creation tools so that students are doing a lot of the work themselves. You know, where could I be engaging them in a more creative digital activity rather than just writing a paper? And then building and working with Adobe has been a real pleasure over the last year to create an integration, especially between Adobe Spark and Canvas now, and we'll continue to work with them to go out. But we really think that that's a key, is connecting the personal learning environment of Creative Cloud with the formal learning environments of an LMS, and there's a lot of strength there.
Well, Wendy, the next question is for you, and I think you know, the tagline is when you're desperate, you invent. But what are some of the surprising innovations you've done on your campus?
You know, I think tagging along with Melissa's comment about that, we had that great boutique training for faculty, and you know, we had to scale that, so it, you know, it kind of ties into that, you know, weaknesses we had to overcome as well. So one of the cool things that I think we did was use the LMS and, you know, create a site for faculty, a Keep Teaching community there, start some discussions going where they could ask each other questions, you know, post the resources in a way that was both searchable and organized in a way that we would like them to present an online course so they could see it in action. And, you know, it shocked me a little bit. I shouldn't be surprised, but how much the faculty were willing to support each other. You know, I mean, that really shouldn't surprise me, but, you know, they would record videos. Here's how I do this, you know, and reply back to one of their colleagues with a video explanation. So that I think was like a great innovation. Recently, we've gamified that. So, you know, we have some awards in there, and, you know, we're playing something called the Field of Dreams, and it has 9 innings, and they can get a single, a double, a triple, and a home run in each inning, you know, which runs each week, you know, and they're kind of competitive on, you know, getting those awards and, you know, wanting to be on that leaderboard and nudging me if I forget to get the leaderboard posted. So, you know, it's kind of fun. And, you know, but that's encouraging some additional engagement in that site, you know, beyond what they were already doing. Because in the beginning, of course, they were, you know, inundated with questions. How do I use these Wacom tablets that we, you know, dispersed out to them, you know, those kinds of things. So that's some of the innovations, using that intelligent agent to enroll faculty in that. So we, you know, had a site going that wasn't quite as organized and engaging, interactive, but we were manually enrolling them. So we quickly figured out that, you know, we could use an intelligent agent to enroll them within hours of them being employed at the university, faculty or staff, they get a message that says, welcome to the Keep Teaching community. Here's what you can find here and here's how you can use it. So that to me, I think was the big innovation, was using our own methods of, online teaching to help them learn how to teach online, which sounds a little obvious, but, did take us a few weeks to get there.
I can mention one thing that we found really helpful in mid-quarter course evaluations and end-of-quarter course evaluations. We took across all of the evaluations that were done online at the university for the open-ended questions about how are you doing in the course, what's working, what's not working, what would you like more of, less of. And we did some machine learning analysis on that data and pulled out themes. And we got a really crystal clear view of what was working and wasn't working for students, what they wanted faculty to do more of, less of. And we got to some of that quality versus quantity issues with course content and tools and things. But something we never thought of in the past, and it proved really helpful in helping our faculty course correct to what students were experiencing. Next question is for you, Melissa. What are some of the new expectations students will have after this pandemic experience? What do you think?
Yeah, I mean, certainly it's a speculation, right? So we've kind of been hedging our bets, I think, a little bit on our campus, thinking that there's a couple of trends that for sure we think students are going to want. And one is flexibility. So depending on the student, some students took this as an opportunity to maybe be able to move with a spouse out of state, right? So somebody had a job opportunity and now they need to continue their education. They want to continue at DePaul. How can they continue to do that? Or just, the savings of not having to commute in, or the flexibility of being able to have a job, or an internship if you can get one of those these days. And so flexibility is really something that we already had in mind and we're planning for. Prior to the pandemic, we had 13 trimodal rooms that were built. We had at that point no use cases for them. We just were like, we think this is the next trend. We're going to build them. If we build them, they'll come. Go back to the Wendy's baseball metaphor there. And then all of a sudden we had a use for them, right? So we're building more of those now. We'll be building 50 more of those on campus. But in the meantime, it also built these Zoom, what we call Zoom Plus rooms. So they're Zoom rooms, so different than a room in Zoom, a Zoom room with microphone technology. So it's a step down from those trimodal rooms. And that allowed faculty to do things like easily bring in outside experts, right? So we saw a lot of that happening in classes this time, and really engaging students where they, these people that would never be able to come to campus and talk to students were being able to come to campus. So I think those types of opportunities for students and being able to bring in outside expert industry leaders into classes, having the students interact with them in really meaningful ways will continue, and students are going to want that interaction to continue. And then the third thing for us is that this is a bet for us, is we only have one college on our campus that currently systematically records classes. It does classroom capture. And we think that it's going to be more demanded by students coming back. They've gotten used to their synchronous classes being captured in Zoom and available to them for review afterwards. So we're in the baby step processes, and we're very backwards with how we implemented Panopto. So we implemented as a end user, student and faculty driven content creation software versus lecture capture. Most people start with lecture capture and add the other pieces in. So we're backwards. So now we're adding lecture capture in. So we're building out a bunch of lecture capture rooms as well, and walking through those steps of how do we roll those out to campus, get faculty on board with it, etc. So we think that again, that flexibility of delivery, the ability to really engage with those experts, industry experts, people outside the classes, and then the ability to review material after class, so you can really spend that time in class engaging, paying attention, asking questions.
Kelvin, next question's for you. After this pandemic passes in some measure, and we're back to face-to-face mostly, what does quality in online teaching and learning look like? How do we ensure that going forward?
Thanks for that, Tom. Well, one, I think that, as you sort of hinted, I think whatever we consider post-pandemic or post-remote instruction probably will vary a little bit institution to institution. There's got to be some unique context there. I said that we're drawing that line this fall 2021 at UCF, but I think of two big things. One, I think we need a higher bar for online teaching and learning. During the initial stages, especially of our pandemic response, our remote instruction response that's still going on, wise voices, wise heads were advocating for empathy, humanity, do the best that you can, let's be realistic, right? And that was the right thing to focus on, and it still is. But if we're going to take a quality turn, it's really important, in my opinion, to set a higher bar and to say we're turning our attention to deliberately online, designed for online experiences that are not ad hoc and emergency. And I think one of the examples is of doing that is having dialogue with faculty, like books like Shannon Riggs' Thrive Online book from Oregon State is a wonderful book that changes the conversation. Not is online good enough, but what does it take to make really good online, and how is that different than making really good face-to-face or really good blended or really good anything else? So that's one thing, a higher bar, reinforcing those messages, making a difference. The other is relying, a part of that is relying on the expertise that's already there in online, right? This is not new. We have a couple and a half decades of research data, professional practice data, and so forth. So let's rely on that, but let's be open-minded about, several of us have alluded to being open-minded to innovate, learn some lessons from the pandemic, but we've got to hold that high bar in order to get there, in my opinion.
Start in the Q&A with Rachel. You asked about sort of the cognitive load on faculty required to teach in a synchronous and face-to-face mode. So, Melissa, what do you think about that?
Yeah, so this is certainly something that we knew was going to be a problem, right? So nobody can say you just stand there and you teach as you normally do, right? Like anyone who tells you that has never been in that situation. So one of the things that we actually did early on was that we hired students. They had a variety of different names. ELF was the original one, but now they're called OLAs, Online Learning Assistants. And they were e-learning facilitators originally. And these students have been invaluable for our faculty. So they are remote participants in the classes. And their sole purpose is, and it's evolved over time. We didn't really know what they were going to do, but it's evolved over time. But their purpose really is to take that pressure off of what's happening in Zoom while I am teaching in the classroom, so that the instructor is focused on the classroom management for the Zoom, for the in-person, and then there's this ambassador that is in their class that kind of helps students who are having technical issues, facilitates things like breakout rooms and polls, since the Zoom rooms don't handle those well, and really then helps support the faculty in terms of getting questions and things like that. They also were invaluable as we looked at, after our first go around with this, what were the issues that they saw students having, especially those remote students having, and pulled together a list of those things. We also did focus groups with students who in the spring or in the fall, I'm sorry, had courses that were in that split modality. And with that information, we just developed our first training for faculty teaching in these classrooms, best practices training that really looked at what are some simple things you can do to make sure that your remote students feel that they're connected, that they're not just an afterthought or just a fly on the wall observer. And what are some things you can do to minimize distraction and things like that. And then we're building upon that now for the summer. And we've built a training that, again, is a work in progress and will be much more like a conversation in which we're going to be training those faculty that will be teaching in these modalities, those 88 plus faculty or so, where we're going to bring in some folks to do some training where they're going to give a lesson. And so some folks that we know have done it well. So they'll teach people, our participants will be remote participants in that situation. So they'll get to experience it. We'll walk through similar to what we do in our online teaching series, where they take a blueprint and they really think about what are the things in their classes that they need interaction. How are they going to manage the split groups? How do they re-envision that? So really getting them to think, go all the way back from a pedagogical perspective and really make conscious and intentional, somebody else mentioned intentional, a couple of people have intentional decisions about their teaching practices. So moving into fall, we hope we'll continue to use those OLAs for assistance. We really found that having an extra set of hands is invaluable, and then hoping that we get folks really in that new mindset that it's not just walking into the classroom and teaching as normal, but instead take some intentional thought and practice.
Encouraging, supporting more authentic modes of assessment.
Yeah, and I'll invite my other panelists to join me if you have ideas. I'll just share a couple. When it comes to authentic assessment, the first thing our faculty discovered is that open book tests are great. They just make the questions harder, and it's really this pivot from I'm not interested in the answer, I'm interested in your process. And that's a real good mind shift for a faculty member. One of the most exciting things I think that we discovered was working with our math faculty. Math can be very much driven by multiple choice exams, but we have some of our faculty who really embraced show your work and a platform, a tool called Gradescope. And what I liked about it was Gradescope uses artificial intelligence appropriately, and that is pointing AI and machine learning at pattern recognition of the product of a student's work, rather than pointing it at the person in their face. And so with Gradescope, we're able to have students show how they're solving a problem, and it really helps faculty then quickly sort who's getting the process right and who isn't, and give really targeted feedback to those who get off base when you can see that they're off pattern. That's just one example. Anywhere that you can give a student a project and then kind of freeze a moment in the project and have the student talk to you about what's going on in their mind and their process, I think we may see the resurrection of the oral exam. And it may be, it's not a big comprehensive oral exam. It may be you're working a project, and at certain check-in points, you have a 15-minute check-in with your instructor where you talk through the process that you're going through and why you're doing it. And I think that's where we begin to get to more authentic assessment. Other ideas?
Let's walk into this minefield a little bit. David Anderson, speaking of running assessments online, mentioned the P word, plagiarism. And we know faculty and students have concerns about how we address that. Is there anything you all panelists have done that you feel has been successful to address plagiarism and faculty and student concerns?
We've done more peer assessment than ever before. That I think can also help there. Peer assessment, group projects, those, and creativity, helping faculty understand that they can give the same prompt for like a paper or writing assignment, but in such a way that that student has to bring in their own experience. And if it's their own experience that they've talked about previous times in the class, the odds of them, you know, being able to source a paper that writes about their experience isn't, you know, going, you know, is much less likely. So, you know, those are the things I would add in.
We've got a good question from Bobby Siegfried, which I think we can close with. So I'm going to skip down to Sean's question about accessibility. You know, moving everything online, of course, makes this much more important. Have you done, panelists at your universities, anything new and different to deal with accessibility issues?
We actually used it as an opportunity to make our courses more accessible. So we actually, in this whole thing, went through a whole process in which we made a commitment. We had some, it's one of the things we spent CARES funding on, was to outsource and make sure that all videos in all classes were captioned. So this was a project that we've wanted to do for a very long time. And now it puts us in a much better position moving forward to be able to caption new things that are added, but really making that commitment to get everything captioned was huge for us.
Wendy?
Yeah, just adding on to that, you know, making sure that we did have some challenges, making sure our faculty had, you know, good headsets and microphones and stuff so that, you know, the audio was clear. But, you know, we did some initiatives there in addition to the captioning. And then one other one was the live captioning for the live sessions. You know, I had a kind of middle of the night panic about that, but, you know, somehow we were able to get a vendor and quickly spin them up, you know, got our legal, you know, and all purchasing and everybody working much faster than we ever thought, you know, it was possible to get that kind of stuff done and get somebody for the live captioning of all of those sessions. So yeah, it was a great opportunity. And we also captioned every single session. We recorded every last session we did for faculty, every last one, and we captioned all of them. And if I forgot or it took a day, you know, they were quick to ask me about it. So.
Well, in the final 5 minutes, I kind of want to ask each panelist just for a short riff. Bobby said, you know, is there a concern that we may be missing a key opportunity to create a new paradigm for instruction post-pandemic, which sort of neatly dovetails with the final question. Do you at your institution envision a continued acceleration in online teaching and learning post-COVID? So, Corey, I guess I'll start with you since you're at the top of the Brady Bunch box here.
Yeah, and I'll be brief so that we get everyone's input. Definitely, I think there's an opportunity here to pivot how we think about what we're offering to students and the kinds of experiences that we're creating. At the University of Utah, we are very interested going forward in saying, no matter what your modality that you're happy taking your classes in, on campus, interactive video, online, we want you to think about the opportunities to use online learning and some of these remote opportunities to connect with curriculum that may not be part of your formal curriculum, but definitely is a part of building skills for the workforce. And so we are really looking at how do we take what has been seen as the separate worlds of for-credit and non-credit and really blend those together and making those non-credit experiences especially available in online formats so that students can augment what they're doing in their program with more of those skills-based short skills snacks, I guess I would call them. And that's going to be a change. And I think it's going to be a positive change for our students.
Thanks, Corey. Melissa, brief words.
So I didn't even set Corey up for that. Those are very similar things to things that we're looking at in terms of, you know, skills-based learning and how that overlays or interacts with what students are doing. So this drive to that students are going to be more skills focused and returning students, right? So the students that are coming back, if we're talking about continuing professional education or degree completion students, are going to be, I believe, more skills focused in terms of how does this get me from point A to point B versus just I'm just here to explore. And there'll always be some component of students who are exploring, but that level of exploration in terms of I would like to try, I want to see what it is to do a leadership, right? But I don't want to take a leadership class. I want to take a short seminar to get my feet wet and get an idea of what this might be. And I think the other piece of this, which I had already mentioned, was that, again, we've asked our deans to all come back and to say, now that you know that these courses, as Calvin said, that, you know, these things that could never be taught online can now be taught online, right? What programs do you envision could be put fully online, and what are the barriers for doing that, and how do we get those offerings available to provide that flexibility for students?
Thanks. Kelvin, parting thoughts on that?
Yeah, I'll take that was all smart and wise, and I agree with a lot of that. And good. A little bit of a different tact, I guess, or extension in a different way is after more than a year of ubiquitous online tool use and maybe for many people, a hunger for in-person experiences, I've been saying, and I really do believe that blended is our future now more than ever. I really believe that. But I don't just mean only blended courses, right? I mean blended experiences. I think it's unlikely that 100% of our campus workforce will be back 100% of the time in offices, and I don't think it's going to be 100% of students in physical classrooms 100% of the time. I think we're going to stretch our sense of what was feasible, and I think that there's going to be a combination of in-person and digital remote co-curricular experiences and student services and mix of modalities and all of that. And we've got I mean, to Bobby's question, right? That's a different paradigm. Maybe not a course paradigm, but that's a different university paradigm.
First thing I want to talk about is the curriculum. If you're going to teach a course on cloud or any other topic, it has to begin with that. Think about what are your learning objectives? What is it you hope to be able to teach these students, or what do you expect them to know by the end of your course? What should they be able to do? And the folks at Google have done, in my opinion, just a fantastic job of creating a fully featured curriculum for teaching the cloud in the classroom. Course in a box, if you like. It includes really everything that you would need just to get started, right? To at least have the skeletons, if not the entirety of what you want to teach in the course. It is very complete, in my opinion, in terms of the topics. It's what you might expect. I think if you sat down and said, I want to teach my students a course about cloud, I come in for my course, I come in expecting really nothing. I tell students they don't have to have experience with cloud, that it's my job to take them from zero to hero. And that's really what you're seeing in this curriculum that Google provides. This is, like several of the resources that I'm going to talk about, something you have to ask for. It's available to anyone who wants it, but that they do ask you to request it. So you write to Google, you say, hey, I'm teaching, and they will facilitate access to these resources. Once you get it, as you'll see, as I'm describing, it is very feature complete. You get a complete course laid out in modules, very methodically, very logically. It's well organized. I think there's strong evidence that there's some folks behind this who understand not just the cloud, but understand pedagogy. If you're going to be teaching this, how would you arrange things? How would you organize things? So it's really well constructed. It comes with a complete set of slides. Every single module has a wonderful slide deck associated with it. And these are really high quality, not the kind of content that I typically put together. I'm not a professional graphics person like most people, but Google has access to those resources, and it really shows. These are excellent, excellent slide decks, really, really nice looking, very professional. It's going to make you look fabulous in the classroom when your students see this. Really, really excellent content. So this is one of my favorite resources, Quick Labs. It's actually an independent company, if you will, that Google acquired, I think, several years ago. And they're in the business of providing cloud training. So these are 100% hands-on training labs in Google Cloud, a variety of topics. I wouldn't even want to hazard a guess. Hundreds, could be thousands of labs, I don't know. It's a lot, and it covers absolutely every topic you would ever want or need to cover in just about any course. And the way this works, there are some free labs, but most of them require credits. And so Google, if you ask, you apply for this, and then if you are granted access, you'll get a large chunk. I think the default is 5,000 credits to share with your students. And so you set this up, you can create a little study group, essentially, just the email addresses of all your students. You have them register to get access to that. It works very smoothly. I've used this for many semesters in the classroom, and with hundreds of students, it works quite well. So they get access, and then they get to work. You can assign these labs essentially just as classroom assignments. So you say, go do this lab, go do that lab. And I can't emphasize enough, this is a live environment. This is not a sandbox where they're kind of practicing, it simulates things. They are getting, when they start a lab, behind the scenes, Google sort of resets passwords and gives them a login to a project that is live inside of Google Cloud. So they are running live, and you have to coach your students on this. They're got to stay within the guardrails of each lab, but they'll be able to work when they say go create something. They're creating it for real in a live Google Cloud region. So that's really cool. To me, this is the way students should be learning, is in a very hands-on, practical manner, getting their hands dirty, really working with this stuff. So it's a fabulous environment for doing that. Again, if that's something that you're interested in helping your students to achieve. Next slide, please. Credits. So this is, I think everyone's familiar with this idea. These are not the kind of free credits that you get. We don't want to mess with that when we talk about teaching in the classroom. This is, you go to Google, again, the link that I'll provide to you at the end, and you say, I'm teaching a course and I'd like to have credits for my students, and they will give them to you. And this is great. You just tell them how many students you have, when your course is, et cetera, provide your syllabus and so on. And the way that it works is you're going to be able to give each student personal credits in the amount of $50. And that may or may not sound like a lot to you. Trust me, that's a fair amount. This will go a really, really long way for one person working in Google Cloud. They'll be able to get a lot of mileage out of this. Instructors, and this would include if you have co-instructors or TAs, are allocated $100 to help you in kind of preparing and monitoring all the work that your students are doing. So it's a really, really great program. So moving on, Code Labs is a free resource. This is not something you have to ask permission to use. Anybody has access to this. It's just an online resource. But what it has is a whole bunch of step-by-step labs or projects, if you will, that you can use, again, for assignments. That's what I find this to be used for. That's what I've used it for. Covers, again, a wide variety of topics. It's not just coding, despite the name. You'll find projects around setting up a dashboard in Data Studio and other topics like that. So you last, but not least, a slightly confusing name here. We had Code Labs. This is CoLab. This is a Jupyter Notebooks environment, if you're familiar with that. We use this a lot in data science, machine learning nowadays. This is, again, a free resource. You don't have to ask to use this. Anybody has access to this, including your students. So you can get them set up and using this the Jupyter Notebooks environment. It's very nicely integrated with Google Drive, which in particular, if you're a G Suite school, this works beautifully. You can have students save their content to Google Drive and bring things in from there, including data. And it's very fully featured in my experience. This is quite an impressive resource that Google makes available. It's not unlimited. You don't obviously get to choose any size of virtual machine where you're running your notebook environment, but it's, I think, more than adequate for this type of use case where you're just trying to teach students. Works especially well, again, if you're teaching machine learning or some kind of data science topic. Now, this is a fabulous way for you to just leverage some free resources, have students work here, create a notebook, they can submit that, turn that into you. And I do want to make note there, you have access to, on a limited basis, both GPUs and TPUs. So that's kind of neat that you can turn that on. So there's the resources for you to link to everything. You go to that top resource, really is the main one. That'll link you to just about everything else to get access to the curriculum, access to credits, access to Quick Lab. And there is a community resource as well, and that is the Google Cloud faculty group that's hosted in Google Groups. Really, really wonderful resource. You've got the Google employees in there, people who work with the education program, making themselves available. They are constantly bringing new content, webinars like this, and it's a great place to ask and answer questions. If you're teaching in Google Cloud, you're unsure, hey, I'm running into a problem with my Quick Labs or credits, how do I do this? It's a great place to get those questions answered.
So that's the goal of this project, is Thunder CTF project. This is a cloud security capture the flag game that's built on Google Cloud Platform that we run in our security courses here. And so I'm going to talk a little bit about the design of this CTF. It's meant to help students engage in securing the cloud and getting practice doing so. And so in terms of its design, Thunder CTF is scenario based to allow students to be able to role play actual exploits in the cloud. It's scaffolded to allow differentiated instruction so that beginners and experienced students can get different things out of the CTF. It's extensible because the threat vectors are changing all the time. So you need to be able to add and remove exploitations as they evolve. And then it's got frictionless setup, low cost, and a polymorphic way of deploying vulnerable projects so that you could deploy this in a classroom and still ensure that every student does unique work as part of this. So the first thing is that it's scenario based. You want to be able to put the student in the shoes of an attacker and as a defender in the cloud. And that's what we do. And in terms of the attacker part of this, it's based on the MITRE attack framework where we try and map the techniques that students are undertaking onto this framework. And this is basically the MITRE attack framework. This is an industry standard way of enumerating attacker behaviors. Across the top, you'll see a bunch of these tactics, which are the general umbrellas of things that attackers would use. There's 12 of them. And then in the columns are specific techniques in that particular tactic. And then an attacker will have a certain set of plays in their playbook that would span different tactics and techniques, and that's what you see in green. And so the idea is to create scenarios where students are going through these TTPs and basically role-playing what it would be like as an attacker to go after a vulnerable cloud project. So this is A6 container, and this is actually modeled after the Capital One breach. So we wanted to model a real scenario and then point students to the actual scenario that was happening. And this Capital One was done on AWS, so we did a kind of a Google equivalent, get an account key, list some instances. You see that this instance is being run out of a container image, and this container image happens to be public. You pull down its image, you see that there's some proxy that's vulnerable to a server-side request forgery attack. You leverage that to pivot into the metadata service that's got access key tokens or access tokens, and then you get access to the data in the bucket. And this is an analog to what happened in the Capital One breach. And then this is sort of a picture of what students do to actually compromise that particular level. That the CTF is scaffolded. So you'll see that CTFs they're mostly evaluative if you actually play the real ones. That's not the point of educational CTFs. We're trying to develop people and get them confidence and competence at the same time. And so it really matters to us to have a differentiated instruction approach to basically gently bring the student into the cloud and into cloud security. And so we have basically this hint system for opening up hints to allow students to eventually solve the level. And so this is an example. There's so for each level, you could either try and do these without the hints, or if you get stuck, you just open up a hint and then you get to the next step. And it treats it as a code lab. If you're using all the hints as a step-by-step recipe, that's basically a code lab. But if you actually ignore all the hints, it's like the CTF, and that's for the advanced players to do. Skip. And then it's easily deployed, it's serverless in its design, so it doesn't consume a lot of credits. You could basically run the whole CTF using 10 cents of your Google Cloud credit coupon that you get. You could use the other $49.90 for other things. The code is freely available for you to use. It's simple to launch, easy to play. It's got the polymorphic flags, as I mentioned earlier. And it's part of this course that we run, Web and Cloud Security. It's one of the labs in this course. And we basically we have custom code labs for all of this stuff. And if you go to this link and you click on the Thunder CTF one, you can play the entire CTF as you'd like. All the instructions are there.
And so we need to put the cloud, the data in the cloud, and then bring researchers to the cloud to analyze the data in place without trying to download and maintain their own copies. Now that sounds great in principle. In practice, there are a number of challenges. Next slide. One of the challenge is that this is a very interdisciplinary area that brings together people with engineering backgrounds, CS computing, and then people with life science backgrounds who typically have very little computational training. They might have computational training from the point of view of algorithms, but not necessarily infrastructure, scaling, and stuff like that. And so teaching, the problem of teaching a newcomer to this field is fairly complicated, because wherever you're coming from, you're bound to lack a whole bunch of vocabulary, concepts, skills, and so on. I had the opportunity to write this book called Genomics in the Cloud that was published by O'Reilly last year. And we basically laid out a roadmap of what are the essential skills and in what order should we teach them to get a newcomer on board, kind of regardless of their original background. And so we start with cloud basics. Next. And here we emphasize very much, we can't teach everything about cloud. And so we emphasize the key things that are really useful in this context. The first, absolutely essential, is virtualization. So talking about virtual machines and containers, what are they, how do you use them? And we try to teach that based on things that we're pretty much guaranteed people are already familiar with. Everybody has at least a laptop, understands having a physical machine and a software stack on top of that. So we teach how virtualization fits and how to think about VMs and containers based on that. Next. We get hands-on very quickly. The entire book is full of hands-on examples and exercises that we have the reader run through. Specifically, we start by just having them spin up a virtual machine on Google Cloud, which is very straightforward, selecting some options out of menus and so on. And then at that point, they're in a shell, they have access to VM, and they can get to work. Very important is teaching people how to interact with data in the cloud. What are the main storage options, the forms in which you store data, whether that's in a data warehouse like BigQuery or in object storage in buckets and so on. Once the data is there, how do you interact with it? Because it's different from just having data on your hard drive or on your network drive. So we teach people how to access, manipulate, write the buckets and so on. And then the third really important pillar in the section is working with containers. Containers are extremely important for scientific research and for reproducibility. It's the best way to ensure that I can share some tools that I wrote, some computational tool that I wrote with a researcher across the world, and make sure that they can run my analysis exactly the way I intended, and then they can build on that and improve it and build their own. So it's really essential. So we teach the concepts associated with containers, and we run through exercises. 5 people pull a container from a registry, spin it up, and run commands within that. Then we have to move over to the genomics side and the basics of working with some of the most classic tools that a researcher will encounter, starting with one that's called GATK for Genome Analysis Toolkit. Next. It's like many research tools, it's a command line based tool. And so there's an official container for this toolkit. We pull it within the VM and we run some typical command lines with some example data that we give them that's in a bucket that we have them copy over to their VM for simplicity to get started. So that's the basics of just what's the usage of these research tools. We move to pipelining because most of those workflows that I just showed you are things you don't want to run those manually by hand. You want to automate them. So next, we teach how to use a scripting language. In this case, it's called a workflow description language, WDL, and we show how you can script operations using this language, which is designed to be fairly readable by people who don't have a strong programming background. And that way you can automate analysis steps. Next, we emphasize specific features of the language that are particularly useful. We don't go over everything, but things like being able to parallelize execution, chunk up a genome in different regions, for example, chromosomes or at a lower level, to be able to parallelize and just make the work go faster. Next. Yeah. In practice, real workflows can get really complex. This is just an example. So we also teach strategies for how to read and interpret a workflow if you stumble across one. There's a lot of exchanging existing workflows and building on existing workflows. We try to avoid reinventing wheels as much as possible in the field. But that means you have to be able to tackle something that looks like that and say, okay, how do I start understanding what this thing does? Because even if you don't write it, you should understand roughly what it does before you start running it on your own data. How do you dispatch work to many VMs? Using that single VM as a kind of a control node, we use certain applications and APIs that are provided by Google that allow us to dispatch instructions to get analysis workflows processed in a very scalable and very efficient way. I hope that gave you kind of a sense of how we design kind of our course to start from the basics and then build gradually to the point that the learner is able to do all the basic operations on the cloud and is then able to move on to more sophisticated research.
I'm going to wrap it up here, and I'm just going to reference these slides will all go out to you. These are a number of the things that Alan spoke about, not only the Quick Labs training credits, but the cloud credits for both faculty and staff to do some hands-on computing, and then the compute curriculum he also mentioned. Next slide. And there are details here about the ways that you as a faculty member can participate in these programs and a link to the Higher Ed Learning Center. Next slide. And there's the community group that Alan mentioned, and some details about the Learning Center you'll want to check out. Next slide. And here are some resource links. And also in that community site, there's information about the Faculty Experts program that Wu Chang mentioned. So we encourage you to take advantage of all of those. What prerequisite knowledge does Thunder CTF require?
So there is some lecture material that goes along with it, because I think it's hard to do a security CTF without understanding the abstractions that Google Cloud is using to protect those resources. Those videos are available. There's a link to the course. On there, there's a YouTube playlist and a set of slide decks. So all the slide material for that course is public. And then within that, there are 2 modules on cloud security and how cloud security is done specifically with Google Cloud that you would need before. I mean, you could still run the CTF without them, but it helps the student more if you prime them with what are these things that I'm dealing with in the exercise.
I'm curious, does anyone have examples of where this classroom work has led to career opportunities, especially in the cloud for their students? What a planted question, but thank you, Ella.
Definitely in my courses, yeah. I had a student, and I think Google eventually interviewed the student. He is the Google Cloud person at XPO Logistics because he got familiar with the interface, the billing and the account management and some of the other stuff. So he's the man over there. And then we had a former student who actually just joined Google. And as a result, I mean, he had experience throughout his time here doing work. So yeah, I think it's pretty high in demand, these skills. Students are getting jobs very quickly when they're through here, at least in my experience.
Yeah, cloud skills in general, but cybersecurity, totally. Alan?
Yeah, I will just say +1 to that. I've had multiple students come to me after the fact and say, hey, I just had my second interview, I just got this job, and the cloud experience made a difference. So just to underscore everything Wu Chang is saying, employers are very impressed, particularly when students can demonstrate, and that it goes back to what I said earlier, something as simple as those badges. Certainly a certification, if you can facilitate that, that's great. But even something like those badges where you can really show an employer, you know, I've got some demonstrable skills working in the cloud. It goes a long, long way.
And I'll add on my end, it's less about people finding jobs coming out of school, because often we have people who are already on a particular track and are expanding their research career. So it's a little later in the process, but I've had two kinds of feedback along those lines. Of one is people who say they are able to tackle topic of research that they wouldn't otherwise, because the data, in some cases, the data has to live on the cloud and it cannot be downloaded. It cannot be, there are actually measures to prevent download. So the only way is to work with it on the cloud, which is, it requires a cultural shift for a lot of people. And those who are getting there early are getting the early papers with the really cool initial findings. They're going to be cited by everyone. So that's pretty cool. And the other one I would say is that people coming from especially coming from a life sciences background, studied biology and so on, who had never had like programming classes or anything like that. Some have self-taught basic Python and R and things like that, but it's still they don't consider themselves programmers. But after going through this kind of instruction, they feel so much more confidence. Like, oh wow, this is not actually that hard. I can do this. I can use these tools. I can do amazing things. I can do massive computational analysis. I don't have to be an engineer to do that. So it's kind of cool to see the level of empowerment.
Excellent. Yeah, and Dirk, who posed the question earlier, said that he teaches a large course and he gets lots of students who come back and thank him after their internships and jobs.